This week's lecture is going to cover some of the basic information regarding and surrounding groundwater. We will cover the following three topics: what groundwater is, conserving groundwater, and groundwater and geology. So groundwater, the amount of water that rocks or soil can hold depends on two characteristics. One is referred to as the porosity, and the other is the permeability. Porosity refers to the pore spaces in rocks and soil, whereas permeability refers to the ability for groundwater to move through the ground. The water table is the top of the water saturated region in the ground. The depth of the water table depends on climate, season, as well as your location. If you look at this diagram here, there are several other key terms characterized. Groundwater will collect underground if there is, or if the rock or soil is is porous, meaning that it has spaces in between the grains or crystals. There also needs to be an impermeable layer at the bottom of the zone of saturation. That zone of saturation is the area that all of the pore spaces are filled with water. The boundary between the zone of saturation and the zone of aeration is referred to as the water table. And the zone of aeration is the area that, or the region underground, that all of the pore spaces are not filled. This zone of aeration is where we're going to have our infiltration. After you have precipitation, the infiltration, the water will seep into the ground and continue to migrate downward until it reaches that water table. There are several ways that groundwater gets to the Earth's surface. One are through natural springs, as well as through wells. An aquifer is the term used to describe regions where permeable layers of rock and sediment have groundwater in enough quantity to supply wells. Your aquifer is a region underground that has a volume of water that can be used to supply wells. In areas associated with volcanic activity, groundwater may be very hot, resulting in the formation of springs and geysers. And if you have ever heard of Yellowstone National Park, which is a national park in the western United States, bordering on Wyoming, Montana, and I think Idaho, it is very well known for having these geysers where hot, heated water will shoot up out of the ground. We're going to move on to the topic of conserving groundwater, and our knowledge of groundwater is important because, as we've talked about and looked at in prior lessons, there's a very, very small percentage of fresh water that is on the surface. When you get water for drinking or for showering or for agricultural purposes or for any, modern activities, there is a very limited amount that is available at the surface. Much of the water of the fresh water is located underground. And in some areas, you have to really be knowledgeable and conscientious about this water budget, which talks about basically how much recharge or input, how much surplus there is, what the usage is, and the deficit, that all can relate to and lead to the quantity of groundwater that is available. Overuse of groundwater leads to problems such as subsidence, which is when the ground itself starts to sink. And groundwater pollution is a serious threat to supplies of usable water. Groundwater pollution is one reason why it is incredibly important to dispose of hazardous waste in a safe manner or using safe practices, lest the groundwater hazardous waste be disposed of improperly and potentially contaminates the water supply. As groundwater moves through the ground, it can dissolve minerals. This is especially true when groundwater is slightly acidic. And when groundwater is slightly acidic, which can happen for a variety of reasons, none of which necessarily are bad, but if you have slightly acidic groundwater, and it moves through an area where you have specific types of rocks, the groundwater itself can dissolve the minerals. When groundwater cools and evaporates, the dissolved minerals are often left behind as deposits such as travertine, geyserite, petrified wood, and more commonly known as stalactites and stalagmites. Calcite deposits occur when groundwater forms as a travertine. And you can also dissolve limestone, which again forms caves and caverns and features of karst topography. Karst topography occurs when rainwater containing carbonic acid seeps into the ground. The limestone dissolves, forming underground caves. If those caves form below the water table, it can be filled with water. And if not, you will have these formations, stalactites and stalagmites. Again, this occurs and is in areas where limestone is the predominant underground rock. And the term karst is how we describe regions that have these features. And that's all for our brief introduction on groundwater, conservation of groundwater, and the geology associated with groundwater and groundwater deposits.